All right, so this video goes over the graphing of the exponential functions with a base of e. Okay, we're going to do that just by creating this table of values, and then I'm going to show you using a graphing calculator online as well. Okay, so remember e, we approximate to 2.71828. Okay, so e to the negative 2 power is going to be 0.135. Now you can take that out further, but this is a good estimation for what e to the negative 2 power is. If we plug in negative 1, we get 0.368. Plug in 0, remember anything to the 0 power is 1, except for 0, of course. E to the first we know is 2.718, again, and 28. When we square that, we get 7.389, and you start to see the exponential growth here. And when we plug in 3, we get about 20.086, okay? So the graph of the exponential function looks like this, okay? Horizontal asymptote at y equals 0, the x-axis here, y-intercept at 0, 1, okay, as all exponential functions have unless there's a constant out here, because anything to the 0 power is 1, okay? So again, notice there's exponential growth as you move to the right on the graph. You know, the curve starts to grow at an exponential, what we call an exponential rate, okay? Let's look at number 2 here, all right? Now this is e to the negative x. Now just recently we talked about graphing exponential functions using transformation. So if you'll remember the transformation, when we replace x with negative x, what happens is these x values, these y values are going to flip. So when we plug in negative 2 to the basic function, we get 0.135. Well, that's going to fall here, okay? And so on, all right? So let's plug in negative 2. And you'll see that it corresponds to when x was 2 over here, so 7.389. So when I plug in negative 1 here, we should get that 2.718. Okay, we're going to get 1 here at 0 like we always do. This should be 0.368 and then 0.135. Now, we didn't have a value over here when x was negative 3, so I can't predict what this is going to be. But again, remember when we change x to negative x, it creates a reflection using the y-axis, okay, as that line of reflection, okay? So let's look at the graph here. So let's copy this. I'm going to paste it in here real quick, okay? And I just want to change that x to a negative x, and you can see the reflection, okay? So the original graph is in red, and the graph of the reflection using the y-axis is in blue here, okay? So if you were to plot the points we just put into our table of values, this blue graph is what it would look like, okay? So I'm going to eliminate that. We'll come back to that in a second. And then the last one down here, okay? It's easier just to create this table of values. If you tried to use all the transformations that we've learned, this would become pretty difficult, okay? So let's just make a table of values here for this one. We plug in negative 2. So this becomes e to the negative 1. So 3 times that value. Remember, e to the negative 1 was 0.368. If you were to multiply 3 times that, you would get 1.104, all right? When we plug in negative 1 here for x, you get 1.8, okay? When we plug in 0, so this e to the 0 part would be 1, and then multiply that times 3, so we get 3 there. When we plug in 1, it's 4.946. When we plug in 2, 8.155. And when we plug in 3, it's 13.445. Okay, so again, you see the exponential growth here. It's slowed down a little bit by the fact of this coefficient of x here. But the larger x gets, you're going to see, you know, a rapid growth down the line. Okay? All right, so let's look at that one. So the graph was, so we had 3 times e to the 0.5x. Okay? And if we were to plot these points that we just had in our table of values, you would end up with this green graph here, okay? So that's how you graph the exponential functions with a base of e.